All right, let's get into it. We hear all the time about AI doing these incredible things, but there's this huge question just sitting there in the background. How do we make sure it's actually safe? In this explainer, we're going to break down that whole complicated world of AI safety, starting from the big philosophical ideas and taking it all the way down to the actual code. And, this isn't some science fiction future we're talking about. It's happening right now. AI systems are deciding the news you see. They're helping doctors make diagnoses. They're even driving cars. Like this one, right here, figuring out that's a person in the crosswalk. Every single day, AI is making thousands of these little calls that have very real consequences. And that, right there, is the core of it all. It's not just about an AI being smart, it's about it being trustworthy. How in the world do we build systems that we can actually rely on to make decisions that are safe, ethical, and genuinely helpful, especially when the stakes are so incredibly high? To even begin to answer that, we have to start at the very top. I want you to think about this whole thing like a funnel. We're going to start at the widest part, the big, broad ethical principles. This is the why behind AI safety. What are we even trying to accomplish here? Luckily, we're not starting from zero. A few years back, the European Commission put together this team of experts to create a framework for exactly this problem. They basically drew a map of what trustworthy AI should even look like. And this is what they landed on: 7 key requirements. You've got things like making sure a human is always in the loop, guaranteeing fairness, protecting our data, and holding these systems accountable. Think of these as the North Star, the guiding principles for anyone building AI. They all kind of work together and support each other. Okay, so for this explainer, we're going to start moving down that funnel. We're going to focus on just one of these 7 principles: technical robustness and safety, because this is the point where those really big philosophical ideas start turning into real, concrete engineering problems that someone has to solve. So, what does technically safe actually mean when you get down to it? We're shifting from the why to the what. We need to take this big idea and break it into specific, measurable goals that engineers can actually build towards and, test. And for that, the Alan Turing Institute, who are real leaders in this space, give us a fantastic framework. They say technical safety really boils down to 4 key pillars: performance, reliability, security, and robustness. So let's break these down one by one. First up, you've got performance. This one's the most straightforward, right? It's all about accuracy. Is the AI system just doing its job correctly? Is it giving the right answers? It's really the bare minimum for any system to be useful at all. Next, we have reliability, and this is a step beyond just being right on average. A reliable system does what its designers intended every single time, even when things get messy. And this medical example is perfect. An AI that helps find tumors can't just be accurate most of the time. It has to be reliable for every single patient, no matter what kind of scanner was used or where they're from. The stakes just don't get any higher. And this slide does a great job of explaining the final 2 pillars, which can be a little tricky. Security is all about defending against bad actors, someone intentionally trying to hack the system or poison its data. Robustness, on the other hand, is about handling the unintentional stuff, like getting a weird, blurry image from an old camera it wasn't trained on. One's a defense against an enemy, the other is just being resilient when things go wrong. Okay, so we've got our big principles and we've got our practical goals, but how do you actually apply all this to the most powerful and, frankly, most complicated AI systems we have today? The large language models that are behind things like ChatGPT. And that brings us to the very bottom of our funnel, the technical how. We're going to look at the absolute cutting-edge methods that are being used right now to teach these giant AI models how to be safe and how to align with what we actually want them to do. With these big language models, the main goal is something called alignment. And an aligned model is one that's trying its best to be 3 things: helpful, so it gives you useful answers; harmless, so it refuses to generate dangerous or toxic stuff; and honest, so it tries to stick to the facts. It's really all about aligning the AI's behavior with our human intentions. So what are we aligning it against? Well, one of the biggest problems out there is something called a jailbreak. This is basically when a user writes a really clever prompt that's specifically designed to fool the AI, to get it to ignore its own safety rules and say something it knows it's not supposed to. And here's a perfect example. Instead of just asking for something bad directly, the user sets up this little role-playing game. It's a roundabout way to try and sneak past the AI's defenses. And believe me, stopping these kinds of attacks is a massive part of AI safety research today. So how do you stop it? Well, the main technique right now is called reinforcement learning from human feedback, or RLHF. Let's walk through it. The whole process begins with a pre-trained model. And the first thing you do is fine-tune it on a bunch of really high-quality examples of good conversations that were written by humans. This first step gives the AI a solid, safe foundation to build on. Okay, so once you have that safe base model, then comes the human feedback part. You have the model generate a few different answers to a prompt, and then you have actual people, human reviewers, rank those answers from best to worst based on how helpful, honest, and safe they are. Now, this next part is really clever. You don't use that human feedback to train the big AI directly. Instead, you use all of that ranking data to train a second, totally separate AI. And its only job is to learn to predict what the humans will like. It becomes what's called a reward model, basically an automated judge that has a good sense of human values. Then, for the final step, you let the original AI go wild, generating millions and millions of responses. And the whole time, that reward model is watching it, and it gives the AI a little digital pat on the head, a reward, every time it creates an answer that aligns with those human preferences it learned. Over time, this process literally steers the AI's behavior, nudging it to become more and more helpful, harmless, and honest. So now, let's zoom all the way back out and put all these pieces together. We've gone from these super high-level philosophical ideas all the way down into the weeds of how these models are actually trained. And this really is the whole point. All that technical, nitty-gritty engineering work of alignment and RLHF, that's not just some abstract exercise. It is the real, practical way we actually make those big, high-level principles like safety and accountability a reality. The how is what makes the why actually possible. So if there's one thing you take away from all this, it should be this. AI safety isn't just one thing. You can't just flip a switch and make it safe. It's a whole stack of challenges, all connected. It starts with asking really deep philosophical questions about our values, and it ends with engineers writing code to embed those values into a machine. And that kind of leaves us with one last big question to think about. Methods like RLHF are the best tools we have right now. But as AI gets more and more powerful, this challenge of alignment is only going to get harder. So the question for all of us is, how are we going to keep evolving our methods to teach these unbelievably complex systems the simple, but most important, human values that truly matter?